Alright, I just watched a video put together by a layperson on a 20-year evolution experiment with E. coli. This is a pretty famous experiment. Basically what they do every day is they take a flask of E. coli, they let it grow, and then at the end of the day they switch it over to, they take a small tiny bit of the flask and they switch it over to a new flask so that the E. coli can keep going, keep generating. E. coli grow very, very quickly, so you have to take only a very small amount of it to transfer over. Otherwise, you just end up with too much. It would be overwhelming, and you'd be wasting way too many laboratory materials. But anyway, the layperson who made this video did a really, really good job putting it together. I was quite surprised. If I were a teaching assistant in a classroom, I'd have to give him an A on his video, hands down. And he described it quite well. He read it out of a Richard Dawkins book. I think it was The Greatest Show on Earth. The problem is that, I'm looking more into the experiment right now. I'm going to be reading more of the details. I've read a little bit about it so far, but one of the problems is that one thing that was said in the video is that citrate, the E. coli were able to digest citrate after X number of generations. And then it said, well, this proves evolution. Not necessarily. This proves that species can have genetic changes over time. But as much as people try to say, well, evolution just means change over time, evolution actually means quite a bit more than that. People try to lump two different ideas together, the idea that species change, along with the idea that all species on Earth had one universal common ancestor that developed by random processes in the ocean billions of years ago. Or maybe not random, maybe it was more chemically directed, but go with me here. Evolution has several completely different definitions that they try to lump all together. It's a bait and switch. That's why creationists, when they talk about species changing over time, they don't refer to it as evolution, because the terms can be confusing. Evolutionists have taken that term and lumped together completely different ideas. And historically, what does evolution mean? It's really come to mean basically this idea that all life on Earth developed from one universal common ancestor. So to take something like antibiotic resistance, which is often the result of losing the function of an enzyme, rather than gaining something new, looking at a loss and lumping that in with this grand overarching evolutionary story is kind of dishonest. It's really propaganda. And in the case of E. coli developing the ability to digest citric acid, I'm actually really not that surprised. E. coli can actually digest citric acid as it is. They just don't digest it under certain conditions, apparently. I had one person send me an article that was probably from the same group. It was a similar experiment that was done, and I'm betting it was done by the same group. I'm betting they were talking about the same experiment. And in this experiment, E. coli were able to digest citric acid. But as I read through it, as I skimmed over the article, one thing that really struck out to me is they weren't sure what the molecular basis for this is. As you can imagine, Darwinian evolution would require, or Neo-Darwinism as it is today, or even post-Neo-Darwinism, any version of Darwinism that's relevant to biology, would require the gain of new information, the gain of fundamentally new biochemical pathways, the gain of fundamentally new regulatory systems, things that are really, really obvious in that they make a more advanced genome, something that's more sophisticated, something that's not like what we've seen before. And I hesitate to say exactly what that would be, because I think that somebody could take an experiment that follows any rules legalistically, but doesn't really show the gain of new information. I've been shown quite a few different examples of so-called evolution in action. One of the examples was a group of bacteria that has developed the ability to digest nylon. And my professor in evolutionary biology was very excited about this. She told us, well, nylon's only been around for X number of years, and so the fact that these bacteria can digest nylon, they developed a new enzyme to digest nylon. Oh wow, that's evolution in action. And by implication, that disproves creationism. Actually, no, because nylon, the structure of nylon was actually designed based on the structure of proteins. And the enzyme that digests the nylon is designed to digest proteins. Now the problem is that the nylonase, as they call the enzyme that digests nylon, all it is basically a enzyme that's designed to digest proteins. So it's designed to digest proteins anyway, but it's a little bit broken, it's a little bit corrupted, so it's lost some of its specificity. It's kind of like if you have a lock and key and you end up breaking the lock, now you can have two keys that go in there. So it would be like if a husband and wife both had two different keys for locking the door. Only the husband's key works, and the wife's key is a little bit different. It doesn't work. So imagine the husband comes along with a baseball bat, smashes the lock, and now it can accept her key too. That's kind of what's happening on the molecular level. Unfortunately, it's a bit of an analogy, so I hope everybody's able to follow me with it. What we really didn't see is the gain of anything new. We didn't see the development of any fundamentally new biochemical pathways, and I suspect that's what's going on with this citrate experiment here too. And like I said, I'm going to be doing more looking into this evolution experiment, which has gone on for at least 20 years now. I've seen articles recently on 20-year evolution experiment. Actually, it was started in, I think it was 1988, so what is it now, 2014? 9, 10, shoot, it's like 26 years now. And I really suspect, looking at this experiment, what I will see is changes in tiny, mediocre, superficial changes in the E. coli genetics. I don't think I'm going to see anything exciting, anything new. I don't think I'm going to see the development of any fundamentally new biochemical pathways. And of course, evolutionists, if we don't see the development of fundamentally new biochemical pathways, they can say, well, they can rightly say, well, maybe there's something wrong with our experiment. Just because they didn't evolve fundamentally new biochemical pathways doesn't mean they can't evolve them at all. That's actually one of the criticisms of Darwinian evolution. Well, actually, it's a counter-criticism. People have accused intelligent design of being unfalsifiable. And I remember an interview with Michael Behe, who's a biochemist. He's one of the main intelligent design advocates. He had this question posed to him, well, isn't intelligent design unfalsifiable? And he said, actually, no, because he claims that the bacterial flagellum, for example, could not develop by Darwinian mechanisms. And he said, well, you know what, if we knock out the genes for the bacterial flagellum and we grow bacteria in culture and we see the development of something like the bacterial flagellum, that would prove that, in his book, that would disprove intelligent design. And yeah, potentially it could still have been designed, but any scientific basis to claim that it was designed would be null. It would be like saying a random pile of rocks on the hillside was designed. But in his book, and Behe has put this forth quite a bit, and he's really one of the main intelligent design proponents, he said that if you can demonstrate that something can arise by mutation and natural selection, then he would say you would have no reason to say that it was designed. He thinks that if we can show that something can rise by natural processes, then we should assume that it did rise by natural processes. And you know what? It's as good as a criterion as any. Yeah, sure. From a, you could have it where God designed an organism and there were a couple things that there was just not time to have them develop naturally, but could have, potentially, had they been given the chance. Of course. But this is a good criterion. If you can show how the bacterium arose by natural processes, then that would disprove the idea that it did rise by that it needed an intelligent designer. So anyway, I'm going to be looking more into this experiment and this 20-year E. coli experiment, and like I said, the guy who made this video, I really wish I could give him I wish I could had a grade book or something, but that sounded a little too high of myself. If I were in a classroom and this guy were a instructor, or not instructor, if I were a teaching assistant for a class, I'd give him an A on his video in a heartbeat, because this guy did a really good job. I want everybody to go seriously go watch his video, post comments. Don't be nasty to the guy. Don't try to jump down his throat or anything like that. This guy did a really good job on his video, and I really want to salute him for it. All right, this is Greg out.